Welcome. Okay, now we're going to go in the next step of the reboot of the battery experiment. We're using, hopefully, my latest information as well as intuition. We're going to, in this video, we're going to be doing the preparation of the powder before we microwave it. The powder goes through a transition from the chemicals that it is into a carbon that is applied on the battery. There are three levels of changes that something can go through. The first one would be carbonization, and that is basically changing it so that the only thing left is carbon. The second one is activation. This is where carbons get pores. They get a lot of extra surface area within them. It also becomes electrically conductive. So this is a very, very good thing for batteries. The third level, which we won't really be getting to, is called graphitization, and that's where you take the carbon and under extreme high heat, the lattice work of the atoms form together, and it makes, in effect, a graphite with layers, and you can even separate the layers and get graphene, that wonderful element, out of it. For this experiment, for this reboot, here is what I'm going to be using. In each of the mugs, to start off with, I'm going to use 4 grams of sugar, some baking soda, urea, and zinc chloride. The sugar is the primary donator for the carbon. It has a pile of carbon, and if you look at it, it's just carbon and water. So you dry out you remove the water, and you end up with a bunch of beautiful carbon. I'm going to be using baking soda in this ratio, 4:1, because of the snake experiments you see on the web, where you use a 4:1 ratio and you see the sugar snake grow up in a wonderful light, hopefully lots of surface area form. The baking soda, when it gets heated, releases carbon dioxide, which is wonderful because as you carbonize things, you don't want to have oxygen in the environment as much as possible, because then they would just burn. You'd get ash, not carbon. Next, I'll have a gram of urea. Urea, when heated, turns into ammonia and nitrogen, and so again, it's a non-oxygen gas, so it should prevent the oxidation of the carbons. And then finally, the zinc chloride. The zinc chloride is what I'm using now instead of the sodium chloride. Sodium chloride melts at a much higher temperature. Zinc chloride melts at a much lower temperature. So I'm hoping that it will melt and it will go all the way around everything and turn into this wonderful environment for making a good carbon. It is still a microwave susceptor. In other words, it gathers and concentrates the microwave energy. I do believe that because it is zinc, we'll have the little miniature sparks, or lightning bolts, if you will, within the ceramic cup. The experiments from Robert Murray Smith seem to indicate that it will take less time than what I've used, and I'm hoping to save a lot of that. Quicker microwave time is great for me because I've got a class with all of these different sets, and so the quicker the microwave time can go, the better. I typically microwave in a ceramic cup, mug, because it should stand 1200 degrees. Now, I have had lots of problems because the ceramic mugs keep breaking. Now, I'm using cheap dollar store mugs, so that's not a big problem, but it'd be even better if it didn't break, and I'm hoping that the shorter times will keep a lot of the mugs intact. I believe each of those sparks, though, is extremely high temperature, and that's where all the reactions happen. I'm going to do something a little bit different this time. Because if you look at all of these ingredients, they are all water soluble. And usually I just put the powders in a grinder, in a coffee grinder, grind them all up, and that also mixes them. It makes it a smaller powder and also mixes them. This time I'm actually going to take the powders and I'm going to dissolve them in distilled water and see if that will make a mixture that is so tightly an intertwined bond that it works that much better. One of the properties of water that is outstanding is the fact that if you have something with a lot of mixture and then something with no mixture, they will blend, and you'll end up with something with just a little bit of mixture. It will blend. So the areas in water of more concentration will actually go over into the areas with no concentration, and it will blend, and it will become a nice even mixture. And so that's what I'm hoping. And so what I'll do is I'll mix it with the least amount of water that I can, because I got to take that back out, and then I'll put the glass vessels in a dehydrator and get rid of the water, and then take those powders, and that's what I'll put into the microwave. So lots of fun, lots of good stuff. Now, I'm going to measure out the powders. I'll keep the camera running, but I'll probably go to fast forward because it's just measuring out powders. It's not a big fancy thing. I will be measuring out double what these numbers are. Sharp observers would notice, okay, I've got double. And the reason is each of my samples in the microwave, I have 2 of the mugs, and so I do 2 at the same time. But by measuring out twice and then doing the processing and then splitting it in half, I really guarantee that I have the same powder in both mugs, and so I should have the same results in both mugs, and that will be more consistent results. So let's get to the measuring out. I should mention one last thing. Do not touch the zinc chloride with your bare skin. Zinc chloride is not an excessively nasty substance. It's just a little irritant in terms of your skin. It's actually used in mouthwashes, so it's not a horrible thing in the right concentrations, but in a concentrated powder it can be an irritant. Don't touch it or breathe it in. On with the measuring. Okay, we have our powders. Now let's add a little bit of distilled water. See how well this can absorb the water. Oh, look at that. Interesting that it's bubbling a little bit. I don't like that. I want to save the gases for release later. You've noticed I've been using fresh spoons for everything. That way I'm avoiding cross-contamination in my products. Okay, just... I don't know why it's bubbling so much. Okay, this is going to take a fair amount of water to get all that powder out. Ideally, and in the future I should be measuring how much water I'm using, how much I'm removing. I do expect it to be just fine. Now even this way, even as a milky liquid, I bet you I'm getting a really good consistency of how intense the stuff is, that it's melting really well. Okay, I've got some big pieces in there. I'm going to go in here and take care of them. I got this mortar and pestle, by the way, from Scientific Surplus, SciPlus.com. Nice little, I really like the stainless steel ones because they're so easy to clean. And then you really know that you don't have any contamination with a future experiment. There we go. Mix it up. Oh darn, we still got a couple little pieces in there. So what I'll do is finish mixing it up, and then I'll put it back into containers this size, a couple of them, and then put it in the dehydrator overnight, and then we should have a powder that we can grind up and then put into the microwave. Thank you very much, and I'll see you on the next video.